Okay, my good friends, it's Roger once again, and today we're starting the new school. I'm not sure what the name is going to be. We're working it out right now. But we're going to start from the beginning. What is matter made of? What is magnetism? What is electrons? What's electricity? What's light? What are all the things that surround us that we really, at this moment, have very little clue about, to be perfectly honest with you? So we're going to start with toys. This is Latham's Crazy Machines. Now, I got all kinds of little magnets and this and that and stuff that we can test and play games with. But let's look at what they're going to do, because this is what's called tractor beam magnets. Now, what does that mean? That means the makeup of what really is an atom. And they're going to make atoms right now. I'm going to show you absolutely phenomenal what they're doing. So this is playing with a tractor beam magnet. I'm just going to let it run. They're going to put a central core inside that is going to be extremely positive. That's our dark matter, you see? And it wants to pull other electrons in. So when we put the dark matter in the center, those extra electrons that want to get into that are surrounded by a layer of electrons, so they can't get through these electrons to get to the dark matter. That is exactly what's happening in atoms, because atoms are made of dipoles, not just one big positive and negative. Watch what happens. Here's the key. This is what's considered to us as an electron, and it wants to get to a positive portion, which is the dark matter, which is in the center. Now, there's other little electrons surrounding that central core. That's exactly what an atom looks like. This is really, these things get stuck. This is truly what an atom looks like if you could see it. Watch as I approach this magnetic material. You'll see that the dark center will grow and the white surrounding will show up. You see it? That's what an atom really, really looks like. We've never seen the inside. All we see is the outside glow. But watch what happens when that outside glow tries to get to the inside dark matter, which we never knew was there. Boop, it stops right there. That's quantum. That's quantum. You're just looking at quantum. They say, well, they get stuck out here just a certain distance from the nucleus because of, then they come up with a whole bunch of nonsense. The reason is this is a dipole, and it already has sufficient quantities of electrons coating the dark matter, so more electrons that want to get to that dark matter because it is extremely attractive. They'll try to get past these white ones, and the white ones will say, no, just stay back. The white ones I'm going to consider is your electron portion. And the dark matter is your muon, and that's collects in the center. It's just the way it works. So this will say, I want to get past you guys, and they say, no, I'm going to push you away with, let's say, 1 electron volt. You're trying to come in with 1 electron volt. Between the two of us, we're going to push each other apart. And I can't let you in. It's called the Kashmir effect. You cannot come closer. Okay, so I claim that the particles that make up a nucleus are nothing but a little electrons, and they have a positive and a negative to them, which we consider dark matter, and, well, muon and electron neutrino. And the muon is dark matter. I'm going to tell you that right now. And that's what they've been looking for right along. It can separate from the electron neutrino. When they come in together, they come in as a box of particles, just like that. That's what a photon looks like. And I'm going to show you exactly this in a second. And as it concusses, it explodes, and the particles literally separate and go their own separate ways and come back instantaneously. So this is CERN's depiction of what they want to see for a muon neutrino staying a muon when it turns Cherenkov radiation, and an electron neutrino turning into electron showers when it turns into Cherenkov. And here they are in our, well, here it is, it's in the same pic, and there it is below. That's exactly what happens. That's the particle coming in, and it was this four-banger, and I'll show you this in very good detail. And then it broke into all the little bits and pieces, and the black balls did not go through the Venturi. So we have a complete separation of power. That's an increase in the energetic value of 200 times from when it started coming in to where it is here. Let's go, and I'll show you that. All right, this is going to take a minute or two to explain, but it's not difficult. This is the light coming in, and it comes in the form of a box like this. And this is what it looks like in its energetic form. When it actually concusses at the Venturi, these particles go their separate ways, just like I said. And here it is happening, right here. This is at the Venturi. They come in this box configuration, and here they just explode and fall apart. That is raw energy, and if we can put a drain right in here, right down into a receiving device, whatever that is, whether it's batteries or direct power or whatever, we can increase the value from 1 to 200. That's a huge increase. We could run 50 or so back in here to keep the process going, and we still have excess free energy. And it's raw free energy. Can be a handheld device, just carry it around. There's no wires, you don't need anything, no grid, nothing. But you need to plug your house into this thing, and it would feed it with electricity. And same thing with your car. I see no problem to do this whatsoever at this moment. It needs a little research, but I would say not even a lot of research. It needs someone, I need an engineering staff to create a harvest device right there. So that when these things become extremely energetic, we harvest the energy value of it. Not just let it go back to turning back into particles, which it was in the beginning, because then we lose all that concussive value. But right in here is a huge increase in electric potential. The electric potential is there. And the potential then goes back into the dark matter because we didn't do anything with it. But if we could harvest it, we could do a lot with it. All right, so this is where we get to all of these little bits and pieces shaking until they form a stable unit at certain frequencies. And these are what's called resonance frequencies. And we are in a resonance frequency universe. Our interactions with the universe creates pulsations of resonance vibration. And everything vibrates at a certain frequency, and at these certain frequencies, you get these particular molecules. I'm still a little confused about that, to be honest. Obviously it's very confusing, but what exactly sets up that stability, and why are some resonances different than other resonances in the same body, and why is some stuff turn into blood and some stuff turns into bone, and some stuff, there's more to this than just the ability for them to break into little pieces like this. There's some other program running that turns them into what's necessary to do the job in the position that they find themselves in, which leads to some serious intelligence. Because if every single one of these is the same particle, how do they get to be separate particles? What do they know? How do they know what to do? How do they know I'm an eyeball? Got a lot of thinking to do. Okay, my wonderful friends, it's Roger Spurr, and I started Mud Fossil University many years ago in response to trying to understand how fossils like this were formed. And I came to the realization that it was a molecular atomic invasion, literally atomic invasion. The atoms that were biological in here were invaded, literally invaded, and substituted with non-organic molecules. Let's just put it that way. They're still organic molecules, but they're now in a condition that they don't give and take with the way organic molecules do. As you live, you give and take molecules back in and out. You take in, oxygen and glucose and minerals and metals and all kinds of things, and then you spit them out, and you go to the bathroom and you pop them back out. So you're in a continuous condition of give and take of the molecules, so nothing is stable. When you die or a creature dies or anything that's biological or organic dies, it either has to rot and dissolve or it has to stabilize. In mud fossil conditions, they stabilize. So let's just get past that. Once I realized the structure, literally the structure of the atoms, they had to be. It had to be, well, let me put it this way. My research led me to the fact that the invasion was happening, and it could only probably happen because of electrons displacing other electrons and forming more stable compounds. How did that happen? Well, we're going to find out right now. Because what you see in front of you is a complete selection of, you got magnets, you've got little electrons, let's call them. You got protons. Okay, we're going to take a look at all of these things and how they react and how particles of light spin through the air. All right, how they are polarized and how they create fields surrounding their polar portions. You see the white showing up there? We're going to get deep into this. It's a little bit of a stretch for most people because they just don't understand it. It's not been thought of in these ways. But there are many different little ways of looking at this that we can prove what I'm saying. I'm not guessing one tiny bit. And you will see that. And if you can put up a defense, I'd like to hear it. And when I say a defense, what am I saying? What would you defend? Well, you would defend the Bohr model, which is the current atomic model that is how electrons and neutrons and protons and molecules and all of that stuff is set up, atoms and so forth. Now, I work a lot with the periodic chart, and I understand it very well. And this is transition metal zone right in here, which is basically what's in your blood. And these transition, they transfer molecules back and forth between the very low electron particles to ones that have a ton of extra electrons. And then they get settled in between in the middle using these metal compounds. What a real nucleus looks like is this. It's not one gigantic proton. Let's take hydrogen. They would say there's one gigantic proton in the center, and then there's one little tiny electron that is trying to get in there, but it can't get in there. All right, that's their impression of a hydrogen. Now, I say no. I say this is a hydrogen. It's completely made of electrons, which makes it a dipole, which means it has a positive and a negative, because electrons are positive and negative. That's never been known before. So this negative positive particle out here wants to get in, but there's so many extra negatives coating this one ball that it says, no, you can't come in here. There's no more room for you. So it stays out there at a distance. Can I show you this in an actually in an experiment? Absolutely, I can. Now, a couple more things to go over while we're here. The core is not one gigantic ball of positiveness pulling on a negative particle. Absolutely not. It is a ball of plus and minus particles, which is the electrons, and they force their dark centers, their dark parts into the center, so it's a coating of a ball of electrons. Now I'm going to give you a quick, like I say, this is a new school. Before we can learn anything, we have to know what an atom is and what everything is made of, and this is what they're made of. Everything's made of electrons, right? Bohr model was the model that they constructed everything, and nothing ever worked. That's why they never even know how gravity works. Not a single thing works correct. I can show we can accelerate light. I show light is these particles, which are electrons. I show that they can separate and actually become the muon and the electron showers. I show all of this stuff, and you'll see them within the next couple of minutes. This is electron flood theory, and it's really more than a theory now. It's pretty obvious it's what's working, and it solves 100% of all material interactions, all energy, all interactions between molecules and electrons and particles, 100%. Outer space, on Earth, biology, 100%. If you can come to me with any single thing whatsoever, I will be able to explain it with electron flood theory, or I will walk away with my tail between my legs. Now, these are electrons, and 1,839 of them make what we would always consider that gigantic proton. And then there's one little bitty electron around it if it was a hydrogen. No, not that at all. It's 1,839 of these particles here make up that core, and then one more wants to get in, just as I showed you. All right, so this is the basic makeup of atoms and molecules. Molecules will still stay that same way, but they will interact with their own little red regions together because they're holding on to each other with a little pull from both sides. That's what a photon looks at concussion. That's what an electron looks like, just sitting around. Now, let's go deeper into the electron flood theory, and I will show you these actual interactions occurring, and I'll explain them as we do. So this is a whole new learning experience, and this is not one big ball of protons. It's a gigantic ball of electrons, and they push and shove each other because they are just nothing more than bar magnets, and then eventually they'll settle into a phase that they are stable. And I will show you that as well in salt experiments. All right, so let's just get past it. What they're going to do is shake. It's going to stay right at that quantum distance. That's exactly how molecules work. When they get so shaken, which means heated and violated and smashed, that particle can disassociate. That's called nuclear decay, because we're in a nucleus now. All right, just so you understand, this is a nucleus. This is an atomic orbital, what they would consider an electron in orbit. And you can destroy particles and make them decay, and that's what he's doing right now by so violently shaking it that the electron leaves and becomes disassociated. That is nuclear decay. And right now, it's trying to hold on, it's heating, boom, there it goes. It's done. Now, let's see what that is actually constructed of in its central core, because right now we're looking at one big glob, not that way. Okay, what we were just watching was Latham's Crazy Machines, Incredible Tractor Beam Magnets. Now, this is the other portion, which is from the amazing resonance experiment. Resonance means shaking at a certain frequency, resonating. Now, this is Bruspup, and real good guys. This goes back many years. These are 6, 7 years, 8 years ago that they did these experiments, and I was fully into this, and that's when my electron flood theory was pretty well locked down. Now, this is nothing more than salt. What is salt? Salt is, on a periodic chart, it's NaCl. Well, what does that mean? Both sides of the periodic chart. So this one has only one electron, that has 7 electrons. That means they're like polar molecules. One side of the salt has extreme amount of electrons, the other side has none. So it basically forms a little tiny bar magnet. What is it sitting on? It's sitting on a plate of steel. What is steel? Steel is nothing more than a series of little particles like this, just like that. Now, when they're not magnetized, they're just sitting there, but if you shake them, they will create, the electrons will push back up and down on the surface. So it will create what they call a resonant shaking vibration. And it shakes these little bar magnets, which are the salt, and then they fall into a pattern at exact frequencies. Hertz is the number of cycles per second. So if we shake it 345 times a second, this is what's going to show up, and that to me is hydrogen. All right, here it goes, boom. 345 cycles per second. They just had salt shaking around or just laying around, which is nothing more than these particles. They're all just laying all over there. Then when they vibrate them at this exact frequency, they lock in. This is the nucleus of a hydrogen, and it has the capability of having 4 orbital electrons, 4 areas where electrons could exist. And I'm starting to wonder whether if they're talking about electrons or they're talking about the dark matter. And we're going to get into that too, because this is where the dark matter exists. This is nothing more than one of each. It's a positive and a negative at the same time. White matter and dark matter. Now, as we go up to the next, see this is what's called a rule of 8. You see 3, 6, 8. There's going to be surrounding the nucleus will be 8 electrons. And they go up and you just keep higher and higher. See, the hertz keep getting more and more, and it just keeps shaking, and they just keep locking in as you get to these frequencies. And they're very elegant patterns. And those patterns are because these little tiny bits are shaken back and forth, and then they say, okay, collect all that dark matter in the center, surround us with a little more dark matter, then let the white particles push and shove each other out here. Just get everybody in a pattern and we'll be stable. That's what molecular stability is. As far as I can determine, and this needs a lot of discussion. There's a lot to talk about here. But I'll show you our light experiments, and I can show you that we can divide these particles, and the particles we're looking at, I can explain. Now, I want to talk to these people like Sabine Hausfelder. I tried to contact her, and of course Don Lincoln. He did contact me back saying, no, I wasn't right, but I would like to have a little more discussion than just that. So here goes. Okay, my wonderful, wonderful friends, Roger once again. Today we're going to be talking about dark matter. And this is Fermilab, they're the big guys. Amazing ways to look for dark matter. Well, dark matter is what is at the center of a black hole, but it is also ubiquitous. It is everywhere. Let's take a look. Oh, by the way, this is Don Lincoln from Fermilab, and he's a spokesman for him, and he's talking about, you know, what is the source of dark matter and how are we going to look for it and how can we tell it, and gravitational lensing and spinning and all this. And they realize there must be more mass because they see these things spinning much faster than they should be spinning. And they contribute that to the fact that there must be more mass in here than is seen, basically. And that mass makes it so that it spins much, much faster as it approaches that mass. It's similar to a figure skater pulling her arms in. As they spin faster and faster and faster, zoom, just like a rocket ship. Well, that's what these are doing. However, what's happening is the dark portion of the particles is moving to the center, and the explosive portion of the particles that wants to move away is moving to the outside. They can separate charges. I've shown it. And I'd like to interact with all of these people. That's why I'm starting the new university. It's going to be called World Forum University. And it's going to be a place where we learn, and we all learn from each other. It's not going to be dictated from the top down. It's going to be sideways. Everybody is going to pay attention to what is basically obvious at this point and has been overlooked and rejected and denied. And now we're going to look at it, and then, you know, maybe there's some mistakes, maybe there's some correct things. But I can tell you one thing right now. Virtually everything that we have been told needs to be re-examined. I'm going to just leave it at that. Okay, I could easily drag this for hours now. This is the science asylum, and dark matter exists, and here's how we know. Now, they really don't know for a fact. I can actually show you it existing, but when they're talking about when it was just the weird motion of galaxies, they really couldn't take it seriously, because they would see galaxies doing things they really didn't expect them to see. But then they realized that the dark matter was actually collapsing, just like the way a ice skater spins, and they pull their arms and they go fast as a rocket ship. And that's exactly what they observed. And then they said, well, there's something going on that's making that stuff pull together. That's when they came out with the idea that there had to be massive quantities of dark matter, not just an equal amount.
Weird motion of galaxies, we couldn't take it seriously. Dark matter wouldn't be taken seriously until Vera Rubin's measurements of galactic rotation. Then we discovered gravitational lensing around seemingly empty.
Gravitational lensing is another situation where the light is being changed due to densities of what it's moving through, basically. And I could show you all of this stuff in our experiments. So let me show you my experiments first, and then we're going to go into Fermilab and Don Lincoln and Kirsty Duffy and Kirsty Duffy and all these people that are making all these statements about dark matter. And there's a lot to be said about it. Now everybody's talking about dark matter. You know, dark energy, dark matter. I tried to get a hold of Christine or Sabine Hofstensfelder. Same thing. She cut me right off because there's no way for any of them to respond to what I say in this dark matter realm, because I have the evidence and they don't. They have theories, and now their theories are under threat, and they just seem to not be concerned about confronting the threat.